Hello everybody. In this video, I'm going to go over a little bit of this hypothesis testing practice using our one sample hypothesis testing flowchart. So yeah, let's go ahead and take a look at some of these. All right, so to get started, Aerotech Manufacturing produces precision aerospace components, including metal fasteners used in commercial jets. Industry regulations require that the average tensile strength of a batch of fasteners must meet or exceed a required standard of 500 newtons to be certified for use in aircraft. Historically, Aerotech's quality control team used supplier-provided tensile strength ratings, but recent failures have led them to perform independent testings to see if the strength on average is lower than expected. The quality control team selects a random sample of 60 fasteners from the latest production run and records their tensile strength. Since the population standard deviation is unknown, Aerotech must use a sample standard deviation to estimate variability. They will conduct a test at the 2% level of significance to determine whether a batch is not meeting the required tensile strength. Okay, and let's click to see our data. So first things first, I'm just going to highlight my data. I'm going to copy it over. And I'm going to go ahead and paste it into Excel. Just do a paste special and do text. And here I have all of my tensile strengths. So let's go ahead and just start off from the top real quick and we'll just work our way down. So step one, what is our business decision? So our, our business decision that we are interested in, let's do that. Okay. My business decision is trying to understand do the fasteners meet quality control standards? So that's like our basic decision question. And we're asking specifically, what is the bolt's tensile strength? Or we'll just put in what is the bolt strength. And we're going to record the strength in newtons and the data type for this one that we are doing is going to be numerical, and specifically it is ratio. And it's ratio because strength is, it has a real zero in it, meaning that when you have a tensile strength of 0, you can't have any strength of less than 0, so it is a real 0. So we've got a numerical. So we want to know a true mean. This is all coming from our step 1 up here. And so our symbol of interest is going to be mu. So fantastic. So we got through step 1. Let's go ahead and do step 2. Our population is going to be bolts from the supplier. Oopsies. Supplier, and our parameter. So thankfully, we know that from step 1, what we want to know is a true mean. So our parameter is going to be the true mean tensile strengths. True mean tensile strength. Okay, great. So now we can go ahead and get on to step 3. So our step 3 is going to be our hypothesis test, where we are now going to be able to set up, let me scroll over just a little bit, our hypothesis, and to set up our null and our alternative. So I'm going to do just h sub 0, and for here we'll do, remember this can be h sub a, or you will see this as h sub 1. Either of those are correct. And if we notice up here, since we're dealing with means, we're going to focus right here. It says that we're going to have mu as our first symbol right here. So we're going to say that mu, and I'll put the other one down here too. Oops, mu. And we need to know if this is going to be, for our alternative hypothesis, less than, greater than, or not equal to some baseline value or some hypothesized population mean. So I'm just going to put in that mu sub 0, or I'll call this like mu naught, the hypothesized true mean is some value up here, what we think the baseline strength is. All right, the baseline strength up here looks like that it's 5,000, that this is our standard that we need to make. So I'm going to say 5,000. So in order to do our mu here, we are going to say, and we want to see where it is, the quality control team. Recent failures have led them to perform independent testing to see if the strength on average is lower than expected. So we want to test to see if we can show that the true mean is less than this 5,000. So it means that the null hypothesis, how I teach it in like my videos, has been equals, but sometimes you will also see it be opposite with an equal sign than the alternative hypothesis. So that would be greater than or equal to 5,000. Okay, so now we've got our null and alternative hypothesis, and I'm going to say like number of tails. And if we look down here in our step 3, notice the inequality, the less than, greater than, or not equals to, and the alternative hypothesis is set in the scenario. The null hypothesis is always opposite of this symbol. And it's two-tailed if the alternative hypothesis is not equal to, and one-tailed if the alternative hypothesis is either greater than or less than. So the number of tails here, we've got a one-tailed test. Okay, moving over to step number 4 is we are going to set up our alpha level from our problem. So we want to know what is alpha. And if we see up here, notice how it says the 2% level of significance. This is an alternative way of saying alpha without actually just saying the word alpha. So we're going to put in 0.02 as our alpha level. Let's go to step 5 now. So if we scroll over in our flowchart, step 5 is saying determine our testing method. So our question is, are we dealing with means or proportions? And we're not dealing with persons, we're looking at means. The next question is like, are we dealing with a difference in matched pairs? And the answer is like, no. Next question is do we know the population standard deviation? And up here it specifically says that since the population standard deviation is unknown, we must use the sample standard deviation. Sometimes they'll say this, sometimes they won't say anything, and they'll either give you the sample standard deviation, like they'll say we took a sample of 60 and we found the mean and the standard deviation, or they just give you the data and we can find the sample standard deviation and the sample mean. So what we are going to be doing in step 5 is a one sample t-test of means. All right, let's go ahead and do step 6. So in step 6, we're dealing with numerical data, and we're going to look at checking our assumptions for our central limit theorem. And we can just simply say that the CLT is good because our sample size is at least 30. So we're good there. So we were able to reach that, and things are totally fine there. So if we go to step 7, there we go. Step 7 is where we actually gather our data. So we can now say, look at the sample data. Fantastic. Now in step 8, we can actually do something. So we can calculate our test statistic, our p-value, and t z-crit or t-crit. We should probably just take that out. That was, whoops, don't need to do that. Okay, never mind. I will edit that out later. So we need to calculate our test statistic, the p-value, and the z-critical or the t-critical. Those are the things that we're looking at. Okay, so first things first. We need to figure out which column we're going to be dealing with, and we don't know the population standard deviation, so let's get focused in on the spot here where it tells us the sample, or we know the sample standard deviation, and we know our t-score, so this is what we're going to be using. First thing that we need to know is, I'm just going to label a few things. We need to know x bar, we need to know mu naught, and we've already got mu naught established up there. But I'll write it one more time. We'll do mu sub 0 equals, we need to know our sample size. Oops, let me pull that over. Let's pull it over here. Our sample size. We need to know our degrees of freedom, and we need to know our sample standard deviation, and we need to know our standard error. So let's go ahead and grab those things really quickly before I do too much else. So for our X bar, we're just going to do equals average of our data set. Click on the first one, Control Shift down. And before I hit enter, instead of having to do that Control Shift down over and over, I'm just going to copy the range that it selected and I'm going to hit enter. Okay, so I've got my sample mean. And then here, for my population, for my sample, for my hypothesized population mean, mu sub 0, I already set it equal up here. It was equal to 5,000. N, I'm just going to say count A of the range that I have, and it says that I have 60. Our degrees of freedom, okay, so it's not stated here, but if you go back to page 3, remember that right now our degrees of freedom are just equal to our sample size minus 1. Gives our degrees of freedom. Our standard deviation of the sample is stdev.s. And let's go ahead and paste in the data. And the standard error is going to be equal to this sample standard deviation divided by the square root of our sample size. That gives me my standard error. So I've got all of the steps here. So now I can say that, okay, my t-score is going to be equal to my parentheses. Do not forget your parentheses or you will not do the calculation correctly. We need to do x bar minus our mu naught divided by our standard error. You can hit enter. There's my t-score. It's okay that it's negative. Remember, t-scores and z-scores, they tell us the number of standard error this sample statistic is from our population parameter. And so we're like -1, so that means we're basic, or -0.9, which is almost one standard deviation or standard error lower than the hypothesized population mean. So there's our t-score. We can now do our p-value. Now let me scroll over and kind of zoom back out just a little bit. When we do our p-value, we have 3 options here. Notice we have a p-value 2-tailed, 1-tailed, and 1-tailed. And we need to match up these symbols with whatever we have in our alternative hypothesis. So notice how our alternative hypothesis is less than. Here we want this p-value of 1-tailed of the less than. So just move over, and it's t.dist of t, the degrees of freedom, and true. So let's do our p-value. And this is going to be equal t.dist of the t, what we just calculated, comma, our degrees of freedom, comma, true. That gives me my p-value, and the p-value is the probability of observing the sample statistic or something more extreme, given that the null hypothesis is true. Okay, and let me finally get my t-crit. Okay, and we need to know if we're doing a 1-tailed or a 2-tailed. We already said that we're doing a 1-tailed, so let's do this one right here. And this is going to be equal to t dot inverse of 1 minus our alpha. So I'll go click up on our alpha, and comma, we need to give it our degrees of freedom. And hit enter. And this is the t-critical, or how far away from our population mean does our sample mean need to be in order for us to think that the true population mean is actually less than 5,000. Okay, so we got through step 8. We got through our t-score, our p-value, and our t-critical. We're on to step 9. We need to say, are we going to reject or fail to reject? So you can do a quick check real quick here. We can say, we can look at our p-value, or we can just say, how do we want to do this? So step 9, if we say, we look at this, it says, hey, the p-value is greater than or equal to alpha, we're going to fail to reject. The p-value is less than alpha, we're going to reject. Okay, so our p-value that we got was equal to 0.18. So we have our p-value, and we can just say equals this 0.18. And we can say again that alpha equals, and we can do 0.02. And we see that our p-value is greater than our alpha. So we are going to fail to reject because p-value is greater than our alpha term. Okay, so step 10. Let's see what we can do. So we'll write out our conclusion real quick. So we're going to say we collected insufficient evidence, and then I'll put in my evidence. So I'm going to put t, and I'll put in my degrees of freedom, which was 59, And my t-score that I got was basically negative 0.92. I'll put in my p-value, which was equal to 0.18. And I'll put in my alpha, which is equal to 0.02. And we'll say, so we collected insufficient evidence to reject the claim that the true mean tensile strength is greater than or equal to 5,000 newtons. And then we will continue under the assumption that the bolts have sufficient, that the bolts are meeting requirements. Okay, now one more thing that we sometimes do is that when we fail to reject the null hypothesis, we typically don't do a confidence interval, because since we rejected the null hypothesis, the confidence interval would contain the null population parameter. But let's go ahead and do it real quick. So notice how it says, if we're going to do a one-tailed and we did a less than test, which is what we did, we're going to do an upper-tailed confidence interval. So let's go back to page 3 real quick. Let's scroll on up to our confidence intervals. Notice how we have numerical or categorical. We know we're dealing with numerical. We know that we only know the sample standard deviation. And we know that we want to do an upper tail because we want to say that we want to be less than or equal to some value. Okay, so notice that here, let's just do a confidence interval. Let's see everything that we need in order to do our confidence interval. We need to know our X bar, our T1 tail critical. And we have that. We just calculated that just a little bit ago. And we need to know the standard error. So it's like we can figure out our confidence interval real quick. So the lower and the upper. So since we're doing an upper tail, the lower tail is going to be negative infinity. Or we'll do INF. Negative infinity. And the upper is going to be equal to, we're just going to follow this one right here where it says X bar. We'll grab X bar plus our T critical one tail, here we go, T critical one tail, times our standard error. We've got our standard error here. And now we have where we think that we are 90, since we have an alpha level of 2, we are 98% confident that the true mean tensile strength is less than 5,022 newtons. Notice how 5,000 is within that range. And so we are like 5,000 is a plausible value that the population could be. Our data did not show that it was less than that 5,000. Okay, so we spent a whole bunch of time doing this. Let's actually go back to the problem now and see what we can do. Let me go ahead and open this up. Okay, so the first thing here, calculate the sample mean and the sample standard deviation. Okay, our sample mean was 4982 and our standard deviation was 146. And so it looks like that we've got that guy right there. Perfect. Okay, what's the null and the alternative hypothesis? Well, we want to be less than, and so we have that the mean set is less than. Okay, what is our test statistic? Our test statistic that we calculated was negative 0.197. What's the computed p-value? All right, let's go down to our p-value, 0.18. There we go. What's the critical value for this hypothesis test? Okay, well, we know that it was a t-critical because we were doing a t-scores. So we know that it has to be one of these two. And we want to know, is the t-critical, is it going to be positive of negative? Okay, so we want to say, is it a critical positive since we're using a one-tail test with a small sample and unknown population standard deviation? Or is the critical value t is equal to -2 because we assume the population mean is decreasing? Okay, this is the one that we want. We want that our t-score, this over here is just like our absolute value. But this is it's negative because we said that from our null hypothesis that it was less than. And so the t-critical is going to be negative 2.1. This t critical is the absolute value that we're able to get. Okay, the correct decision, we said failed to reject. And so that's going to be one of these two. So if we do fail to reject, there's insufficient evidence to suggest that the batch fails to meet the required tensile strength. Or is it failed to reject, conclude that there is sufficient evidence to suggest that the batch fails to meet? And it's like, nope, we don't have enough evidence to suggest that it's less than 5,000 or that it fails to meet the required tensile strength. All right, so then what's the 98% confidence interval? Well, we go from negative infinity to 5,022. So we're going to grab that guy. What does the confidence interval mean? So the confidence interval means that if we were to conduct many similar samples, approximately 98% of the confidence intervals would contain the true tensile strength. So that is what the confidence level means. So the confidence level of like 98 or 98%. It doesn't mean that we think that 98% probability that the tensile strength is below. They can be used to interpret results, and that since 5,000 is within the interval, this would be true said we cannot conclude that the tensile strengths have decreased. But since 5,000 is inside, like we absolutely can't do what this last one is saying. Okay, do we satisfy the central limit requirements? Well, we satisfied it because we had at least a sample size of 30, so that was good. And what would a type 1 error mean? Okay, this is like the one thing that we didn't quite cover. But let's look at what a type 1 error would actually be in this scenario. Let's go back to our flow chart here. And let's go ahead and do it. Okay, so type 1 error. Let's go to step 4 in here to actually really kind of focus in on what a type 1 error is. So here it says that a type 1 error is when we would reject the null hypothesis, but the null hypothesis is true, or otherwise, we would say that the bolts are failing to meet their requirements, when in reality, the supplier's bolts are of the sufficient strength that is needed, and that would be a type 1 error. So let's see if we can match up anyone when it's here. So a type 1 error would mean we conclude that the batch fails to meet the tensile strength, when in reality, it actually meets it. That one's correct. Let's look at these other ones and see what the problem is. A type 1 error would mean that the sample mean is incorrect. That's not what a type 1 error is. A type 1 error would mean that we conclude that the batch meets the tensile strength requirement when it actually does not. And down here, we would say the type 1 error only happens when the confidence interval is miscalculated. So let's look at this one. This third one is close. Type 1 error would mean we conclude that the batch meets the tensile strength requirements. So that would mean that we would fail to reject the null hypothesis. But in reality, it actually does not meet those requirements. And so if that is the case, that would actually be a type 2 error. Anyhow, that's how we go through and do all of these. So I kind of went through the entire step by step first and then went through. You can also kind of go through, and if you are comfortable with the flow chart, you can kind of jump around and pick around to get these answers a little bit quicker. I also suggest that you read through the questions too to kind of know, it's like, what are we even talking about as we go through? Anyways, I hope that helps you out. Good luck on prepping for this exam.